Question number 37. A potentiometer circuit is used to determine the e.m.f. E of a cell. The circuit includes the circuit includes a second cell of e.m.f. 1.5 volt. Okay, this is 1.5 volt over here, and internal resistance 0.5 ohms. That is connected to a uniform resistance wire XY. Okay, and then uniform resistance wire length 0.96 centimeter and meter and resistance 0.5 ohms. Okay, the resistance wire XY has a length of 0.96 and resistance of 0.5. Fine. The movable connection Z is moved along the wire XY. The galvanometer reading, the galvanometer is 0 when length XZ is 0.64. Okay, so this should be your balancing length. This should be your balancing length. Okay, at this point, no current passes over here. Okay, what is the value of the e.m.f? Okay, in such kinds of questions, the first thing that we need to understand here is when no current passes from here, it is better to detach this circuit. There's no point in using the circuit, right? First thing, any circuit problem when you have, whenever they say that you have multiple circuits and in one of the circuits there's no current passing to it, just kick that out. Okay, remove that out. Okay, so we'll remove this. When you remove this, you only have this circuit. Now let us find out what is the current passing to it. Now the question is very simple. This resistance XY has a resistance of 0.5 ohm. This has 0.5 ohm. What is the current passing through it? Current passing through it, this will be 1.5 divided by total resistance, which will be 0.5 plus 0.5, which will be equal to 1.5 divided by 1, which is equal to 1.5 amperes. Okay, the current through the primary circuit here is seen to be 1.5 amperes. It comes all over here and it passes over here and goes like this. It keeps on circulating like this. Now, when you keep the balancing link, that's this point. Now, what is the question here? The question is, what is the e.m.f. of the cell? Okay. Again, simple thing. See, when does the current, though you put across a circuit is closed, no current passes through it. When does this happen? It happens only when the potential difference across this is equal to potential difference across this, right? When the potentials are same, definitely no currents will pass. It is like having two water bottles, connecting a pipe in between them, and you ask, okay, well, the water can flow from here to here. It will flow only when the heights of these two. So it is like this. See, you take two water bottles like this, put one pipe over here, put one pipe over here, and then, okay, it's like this over here. Okay, so there is water filled here until here, and there is water filled until here, let us say. If there is a difference in water levels and the pipe is open, then definitely water will flow. If there is no difference in water levels, both of them are of the same height, then what will happen? Water will not flow. Water flow is equal to the current flow, and the height difference here is equal to potential difference. Okay, that's how you need to understand electricity. So therefore, now what happens? So the potential difference across this two and this two should be the same. That means if I find what is the potential drop across this one, I would be able to say this is the equal to this one, right? I need to find out this. So how do I find? Current is known. How do I find potential drop? Potential drop V is equal to I times R. Okay, I need to get the value of R. That's it. Now, how do I get the value of R is the question. Okay, now so towards it. Now what is being given here? The given here is nothing but we say uniform resistance wire. That means what? Same resistivity of length 0.96 meter will have a resistance of 0.5 ohms. Unitary method, nothing else. Okay, 0.96 meters has a resistance of 0.5 ohms. What is this length? 0.64 meter. How much will this resistance be? Simple question. Now, how do you answer this? You can just say this resistance will now be equal to 0.64 multiplied by 0.5 multiplied by 0.96. That's it. Get the value of it. So use your calculator. So this would be 0.64 multiplied by 0.5 divided by 0.96. When I do this, I get the answer 0.33. Okay, 0.33 ohm. This is your resistance of this one. Now I need to find out what is the potential drop across this. This should be, what is the value of I? 1.5 ampere multiplied by what is this value? 0.33. Okay, which is 1.5. 0.33 is 1 by 3. The answer should be 0.5 volt. 0.5 volt. Answer is 0.5 volt and 3C. Okay, very simple question, provided you need to know what's going on out here.